Welcome to Chemistry Solutions with Steve, your ticket to exam success. This video is from topic 4.3 of the GCSE Quantitative Chemistry syllabus, and it's a revision topic on relative atomic mass, relative formula mass and moles. It's relevant for all exam boards. Please feel free to pause the video as often as you like and as often as you need to. This video gives you practice in using relative atomic masses to calculate relative formula masses. It also provides you with practice in using these values to calculate the numbers of moles present in a given mass of a substance. The masses of atoms and molecules are so small that we use relative masses in experiments and calculations. If we're dealing with atoms, we use the term relative atomic mass, or the symbol AR. If we are dealing with molecular or ionic substances, we use the term relative formula mass, MR. Sometimes you might have heard this as relative molecular mass, hence the M in MR. The mole is a word we use to describe the amount of a substance. 1 mole is the relative atomic mass or relative formula mass expressed in grams. Here are some relative atomic masses, and some of these you'll be very familiar with. And you will be given these either in the exam question, or you might be asked to find them in your periodic table, which you will also be given in the exam. And you can find a copy of your periodic table at the AQA website. The website address is there, and you just follow the link. There are other versions of the periodic table, but I would suggest that you use the version supplied by the AQA or any other exam board and get to know it and get to know your way around it. So pause the video while you get a copy of this. You can have a copy online or on a screen, or get a printout and put it in a plastic wallet, or even laminate it, because you're going to use it a lot in chemistry. So use your periodic table and find the symbol and relative atomic mass of the element at the top of group 1. So here's a clip of the periodic table, and you can see group 1's here at the top of group 1, the element lithium, and its relative atomic mass is 7. Let's look at relative formula mass. The relative formula mass MR of a compound is the sum of the relative atomic masses of the atoms in the numbers shown in the formula. So here's an example. Find the MR, the relative formula mass of hydrogen, H2. The AR of hydrogen is 1, therefore the MR of H2 must be 2. So pause the video and use these ARs to calculate the MR of the following substances: CO2, H2O, NH3, Na2SO4, MgNO3 bracket twice. Again, if you pause the video, you can work through the answers. Just remember that when you've got brackets, everything inside the bracket is multiplied by the subscript, or the multiplier as we sometimes call it. So, on to moles. A mole in chemistry is a very large number, like a dozen or a score or a century. It's a name for a big number. Because atoms are so small, you can't count individuals. And chemists, they need to make stuff, and they need to know how many of each atom's present, so that they've got enough and that they don't waste any. So, how many items are there in a mole? What is a number? What is the number of a mole? Well, it's 6.02 times 10 to the 23. That's 6 with 23 noughts after it, essentially. Now, that's a huge number, and it's named after, it's called the Avogadro number, and named after an Italian scientist. What does it look like? Imagine a pile of 1p coins piled up. The stack would reach to the moon and back more than 1 billion times. And there's lots of examples of visualizations. If you look on the internet, you'll find plenty. Now we can calculate how many particles there are in a sample by using this simple equation. The number of particles is the number of moles multiplied by the Avogadro constant, and we'll come to this later on. Now, the clever thing about a mole, and this is what Avogadro worked out, is that the mass of 1 mole of an element is numerically equal to the relative atomic mass of that element. For example, the mass of a mole of carbon, C, is 12 grams because the AR for carbon, relative atomic mass, is 12. It works the same for compounds. The mass of a mole of a compound is numerically equal to the relative formula mass of the compound. For example, the mass of a mole of water, H2O, is 18 grams. So that's 1 plus 1 plus 16. 1 hydrogen, 1 oxygen. So now we're at the business end, because now we can calculate the number of moles in a given mass of an element or a compound by using this simple formula. The number of moles is the mass divided by the MR or the AR. And there's a formula triangle here. And we remember this by the phrase Mr. Moles with a mass on his head. Mr. Moles with a mass on his head. That's the formula triangle. You will use that oodles of times in your chemistry life. So if you've got your periodic table handy, let's calculate the numbers of moles in some samples. 6 grams of carbon, 48 grams of magnesium, 4 grams of oxygen, 170 grams of ammonia, 220 grams of carbon dioxide. Pause the video, work them out, and then look for the answers. So, if you can remember how to use the formula triangle, which I'm sure you've been taught before, the Mr. Moles with a mass on his head works every time. You cover up the value you're trying to work out, and in this case it's the number of moles, and then the others leave the sum. So in this case we cover up the number of moles and we have mass divided by Mr. In this case the Mr will be the relative atomic mass of carbon, which is 12. The mass in the question is 6 grams. So the number of moles is 6 divided by 12, which is 0.5 moles. So on to the next one. How many moles in 48 grams of magnesium? It's the same formula, mass divided by Mr. The mass is 48, the Mr for magnesium, the AR is 24. So the number of moles is 48 divided by 24, which is 2 moles. So, the next one, 4 grams of oxygen, the AR for oxygen, this is an O2 molecule, so the AR for oxygen is 16, but the MR, because it's a molecule for O2, is 32. So the number of moles is 4 grams divided by 32, which is 0.125 moles. So, number of moles in 170 grams of ammonia NH3. So now we need to work out the relative formula mass of NH3. So the AR for nitrogen is 14, hydrogen is 1. So the MR for NH3 is 14 plus 1 plus 1 plus 1. That makes 17. So the number of moles is the mass, 170 grams, divided by the MR, 17. 170 divided by 17, 10 moles. 220 grams of carbon dioxide. So let's have a look at the MR for carbon dioxide. Carbon is 12, oxygen is 16. We've got 1 carbon and 2 oxygen, so the MR for CO2, 12 plus 16 makes 44. So the number of moles is the mass, 220 divided by 44, 5 moles. So, you'll often be asked to work out the mass of a given number of moles of a substance, and for this we just go back to Mr. Moles with a mass on his head. We're looking to work out the mass, so we cover up mass, and that leaves us with moles times the Mr. So here's a worked problem. What is the mass of 10 moles of sodium whose AR is 23? As we've said, the mass is the number of moles times the MR, so 10 moles times 23, 230 grams. So let's do a couple of problems. Pause the video and then restart when you've worked out the answer. What is the mass of 6 moles of water H2O? You've been given the relative atomic masses for hydrogen and oxygen. So H2O means we need 2 hydrogens plus an oxygen. 2 plus 16, that makes 18. The mass is the number of moles, which is 6, times the Mr, which is 18. So 6 times 18, That comes to 108 grams. And the next one, what is the mass of 0.1 moles of sodium carbonate, Na2CO3? The ARs are sodium is 23, carbon 12, oxygen 13. 16, beg your pardon. So we work out the MR of sodium carbonate, and it's important that you use brackets here. So we've got 2 times 23 for your sodiums, plus a 12, plus 3 times 16. If you do that on your calculator and use your brackets, you get 106. So mass is moles times Mr. 0.1 moles times 106, 10.6 grams. Operation that you are often likely to be asked to do is to calculate the number of particles in a set number of moles or a set mass of a substance. And so remember the formula from earlier. The number of particles equals the number of moles times the Avogadro constant or number. So let's do a worked example. How many atoms in 46 grams of sodium? We've been given the AR for sodium as 23. So we use our good old friend Mr. Moles with a mass on his head because we need to work out the number of moles in 46 grams of sodium. So the formula becomes the number of particles equals 46 divided by 23 times the Avogadro constant. We follow that through, we end up with 2 times 6.02 times 10 to the 23. Now ignore the 10 for the 23 for now. Let's just do the 2 times 6.02, and that equals 12.04. Now we can't leave it as 12.04 times 10 to the 23 because we need it in standard form. So if we move the decimal point one place to the left in the 12, we add a number onto the 23. So our final answer becomes 1.2 times 10 to the 24. Try this question. How many atoms in 12 grams of magnesium? And the AR for magnesium is 24. Here's the equation. The number of particles equals the number of moles times the Avogadro constant. Pause the video, have a go, and then restart and check your answer. So you've got to work out the number of moles. You were given 12 grams of magnesium. The IR for magnesium is 24. So to sub in the number of moles, we put in 12 divided by 24. That works out to be 0.5 times 6.02 times 10 to the 23. If we follow that through on our calculators, we get 3.01 times 10 to the 23. And if you got that right, well done. Okay, let's look at some extension work. We can use the Avogadro number to calculate the mass of an atom, and you're sometimes asked to do this. What do we know? We know the mass of 1 mole of any element or compound is the relative atomic mass, AR, or the relative formula mass, MR, expressed in grams. Remember, 1 mole of carbon equals 12 grams. The Avogadro constant or number is 6.02 times 10 to the 23. This is the number of particles, atoms or molecules in 1 mole. So, for example, in 1 mole of carbon, 12 grams, there are 6 times 02 times 10 to the 23 atoms. So we should be able to work out the mass of 1 atom simply from that bit there. So the mass of 1 atom is the mass of 1 mole of atoms divided by 6.02 times 10 to the 23. We've missed that bit off there. I'll put it in here later on. The mass of 1 atom of carbon, therefore, is 12 divided by 6.02 times 10 to the 23. So we evaluate 12 divided by 6.02. That comes up to be 1.99. But remember, when you're dividing by an exponential number like this in standard form, the sign flips. So that's a positive sign, flips to negative. So the answer for the mass of 1 atom of carbon, 1.99 times 10 to the minus 23 grams, which you can imagine is extremely small. So here's one for you to do. Pause the video and calculate the mass of 1 atom of sulfur. Remember the formula: a mass of one atom is the mass of 1 mole of atoms divided by 6.02 times 10 to the 23. The AR of sulfur is 32, so the mass of one atom of sulfur is going to be 32 divided by 6.02 times 10 to the 23. Evaluate that and you get 5.32 times 10 to the minus 23. So that's the mass of one atom of sulfur. So try this one. Can you calculate the mass of one molecule of water? Pause the video and this time see if you can do this calculation from the beginning by writing out the equation first and then evaluate to the final answer. Then I'll reveal the answer and see how you got on. So, hopefully you got the formula right. The mass of one molecule is the mass of 1 mole of molecules divided by 6.02 times 10 to the 23. The mass of one molecule of water, therefore, well, we need the MR for water, and it's there down there, look. The MR for water is 1 plus 1 plus 16 equals 18. You might remember this from before. If not, go back on the video looking at how to calculate MRs. So we divide 18 by 6.02 times 10 to the 23. Crunch that in your calculator and we end up with 2.99 times 10 to the minus 23 for the mass of one molecule of water. Thanks for watching. I hope you enjoyed it. I've got more videos like this for revision. We've also got exam walkthroughs, chemistry walkthroughs. If you click on my site, you'll be able to get those. And we'll see you next time.